and we will go to the modeling mode, and let us go to the general mode, general tab I mean, and go to the specification tab. Over here you can see that is specification tab, and here you see different options. I'll just briefly explain what this node specification is. If we click on it, you can see the master slave, and from here you can define a master node. The master node will be the node which will act as the rigid link in the structure, and if you define the master node as a rigid node, you can define any the node number, and you can define the slave node. The deflection of the slave node will be dependent on the deflection of the master node. We might not use this, so I will not go into this thing. What I am concerned here is the beam specification. Click on beam. Over here you can see different specifications, and in this video I'll be talking about this release. I just told you why we want the moment release, or a shear force release, or it can be the torsion release, it can be any kind of release. It is because our members are not perfect. In this modeling, the members are considered to be perfect, they are considered to be rigid, but in reality our structures are not that rigid and not perfect. They undergo certain deflection, they undergo certain rotation, due to which there is distribution of forces or the movement. Due to this reason, in any case, in any structural member, the movement that is induced or the force that is induced in it is not completely transferred to the next member. Certain force or certain movement is redistributed or released. There are two kind of releases. One is the partial release and another is the complete release. Partial release means that if the movement in this column is, suppose that it's 10 kilonewton meter, and if only 50%, that is 5 kilonewton meter, is transferred to the next member, in that case it is called the partial movement release. And in the complete movement release, no movement from this member is transferred to the next member, that which means that 10 kilonewton meter movement will be 0. Let us first see when we need the complete release, and after that we will see how we can use the partial movement release option over here. To explain the complete release or the 100% release, I will first draw a secondary beam in this structure, because in secondary beam we got a complete movement release. And why is it? I'll explain it in a while. I'll just go to the isometric view, and after that I'll go to geometry, and after that what I'll do, I will go to add beam, and I'll go to add beam between midpoints. I'll select this member and I'll select this member. Just click on yes. If you run this model and go to post processing and see the movement, you will see the movement value at these 2 points. You can pause the video and see that. But in real structure, what happens is that the movement at this position is 0. And why is that? I'll explain it to you. To understand this thing, we have to understand how movement is generated in any structure. To generate movement in any structure, what happens is that, suppose this is our structure, okay, I'll just draw a structure, and we apply a load here, a load of 5 kilonewton meter, and this distance is let us suppose it's 4 meter. Okay, if this structure is fixed on the ground, what will happen is that when you apply the load of 5 kilonewton meter, it will try to resist this load. And when it is resisting the load, the counter movement, that is 5 into 4 is equal to 20 kilonewton meter. So this movement will be clockwise and the anti-clockwise movement will be induced at this position. If this structure fails to induce this much of movement, it will rotate or it will crack or it will fail. If there is a hinge over here, suppose that if there is a hinge and you apply a load of 5 kilonewton meter, it will just rotate like this, which means that it cannot resist this much of movement, this much of 20 kilonewton meter movement, due to which we say that the hinge supports do not give any movement. The movement at this position is 0, due to which it cannot resist this movement. So we know that if any structure resists certain movement or certain load, the movement or the counter movement is induced in that structure. In secondary beam, what happens is that if this is these two are our primary beams, okay, and this is our secondary beam, Okay, in normal beams what happens, so if these are our normal beams, okay, a slanted structure, but I hope you can understand this. If this is our normal beams, in normal beams, when there is load on these beams due to the support from the columns, what happens is that this portion or this joint, the beam column joint, it doesn't undergo any kind of rotation due to the support from column. When it doesn't undergo any kind of rotation, it induces the counter movement, and we say that it gives certain movement, right? And the movement diagram or the movement value is produced here like this. And if we see the movement diagram at this position, it will be we just saw, right? It's something like this movement diagram is induced here. But in secondary beam, due to the rotation of this junction, when the load is applied on this beam, due to the rotation of this joint, no movement is induced at this position, and we say that at this position the movement value is 0. But as per your current modeling that you have done in Staad Pro, save it, movement is induced here, and we have to tell Staad Pro that at these two positions there should be no movement. For that we use the full movement release option that I showed you minutes ago. Let us see how we do that. Go to beam and click on, your location should be start, and the release type should be release, and let us release the movement in the Z direction. And if you check from your movement diagram, if there are movement in the Y and X direction, you can release them as well. This is the movement in the Z direction, and this is the stiffness due to the movement, and these are the shear forces. In secondary beam, the shear force is transferred, so we won't be releasing shear forces. This is a complete release, which means that the movement in the Z direction will be taken as 0 at these two positions. So what we do, we click on add. It is at the start position. Now again click on beam and click on end and click on MZ, and after that click on add. Now we have to assign these two properties or specifications to the secondary beam. What do we do for that? We select the beam by using the beams cursor, select the beam and select in MZ and click on assign to the selected beams and click on assign and click on yes. You can see that at the end position the movement has been released, and again click on start MZ and click on assign and click on yes. Now if we run this model, go to analyze and click on run analysis and click on save. Two errors. Let us see what the errors are. Okay, so elastic modulus E is not okay. We haven't assigned the section into the secondary beam, so what we do, we go to the property and check this option, select this and click on assign and click on yes, R1. Now we analyze the structure, go to analyze and click on run analysis and click on save. 0 errors now, and go to post processing mode and click on done, click on OK. Now if we see the movement diagram, click on MZ, you can see that movement at this position is 0. There is no movement at this position. This is where the complete release or full release option is useful. Also in case of truss, in case of truss where the truss are connected by the bolts or the rivets, if this is your truss member, if this is your truss, and if these truss members are connected by bolts or rivets, in that case also at these joints the movement release is complete because no movement is induced at these positions.